Welcome to this comprehensive training video on C# built-in delegate types. These are essential for building robust and responsive modern event systems in your applications. Understanding them is a cornerstone for any C# developer looking to create dynamic and interactive software. Delegates in C# act as type-safe function pointers, allowing you to pass methods as arguments. This capability is crucial for implementing flexible and efficient event-driven programming paradigms. It enables actions to trigger responses across different parts of your application, fostering a highly responsive system. Historically, developers declared custom delegate types, which often led to verbose code. This required explicit delegate keyword declarations for every unique method signature. Such verbosity and lack of standardization made code harder to read, maintain, and share across projects, introducing unnecessary complexity. Today, C# offers modern, built-in delegate types such as action, func, and predicate. These types cover most delegate use cases, dramatically simplifying development. Leveraging these standardized types allows developers to write cleaner, more concise code, streamlining event handling and method passing within applications. Let's begin with the action delegate, designed for methods that do not return a value, meaning they are void. These delegates are versatile for executing side effects, such as logging messages or updating UI elements, without expecting a result back from the operation. Here's a simple example. We declare an action string named greet. This delegate takes a string and prints it to the console. The lambda expression equals console.writeLine defines this behavior, demonstrating a clear, void-returning operation. We then invoke this action by passing a string argument, for example, greet. The associated lambda expression executes immediately. As a result, hello, world, appears in your console, confirming the method referenced by the action has successfully performed its intended operation. The action delegate also supports multiple generic type parameters, such as action, T1, T2, for methods requiring several inputs. This flexibility allows action to be suitable for a wide array of scenarios where methods need multiple pieces of information to perform their void-returning tasks. For instance, an action string int can handle both a message and a number as inputs. This demonstrates its flexibility for methods needing diverse parameter lists. It allows you to define and pass around methods that perform void-returning tasks with multiple pieces of information. Next, we explore the func result delegate, used for methods that return a value. Unlike action, func is specifically engineered for methods producing a result of a particular type. This makes func indispensable for computations, data transformations, and operations expecting a meaningful output. With func, the last type parameter always specifies the return type of the method. For example, in func, tinput, toutput is the return type. This consistent pattern makes func delegates highly predictable and easy to understand at a glance. Consider a func int that takes an integer and returns its square. We define func int square equals number asterisk number. This delegate accepts a single integer input and returns an integer result, perfectly aligning with func's design for value-returning methods. When invoked, square would yield the result 25. The associated lambda expression executes, performing the multiplication, and the result is returned. This clearly demonstrates the direct input-output relationship inherent in func delegates, where an input is processed to produce a specific output value. You can also use func for more complex operations like string manipulation, data parsing, or complex object transformations. Any method that takes inputs and produces a single, defined output can be elegantly represented and passed around using a func delegate, showcasing its broad applicability. For example, a func string could convert a string to uppercase. We define func string to upper equals text.toupper. This delegate takes a string input and returns an uppercase string output. When invoked with toupper, it would yield hello. Now, let's look at predicate t, a specialized func that always returns a Boolean value. It takes a single input parameter of type t and evaluates a condition against it. This makes predicate t perfect for conditional checks and filtering operations. Its primary use case is to test if an object meets specific criteria, often for filtering collections. This is exceptionally useful when you need to filter elements based on a specific condition. For instance, a predicate can find all items in a list that meet a particular property, streamlining data selection. Here, we define a predicate int to check if a number is even. The lambda expression equals number %2 equals 0 performs this check. It returns true if the number is even and false otherwise, clearly showing its role in evaluating a single condition. When applied to a list, isEven can efficiently filter out odd numbers, leaving only the even ones. For example, using findAll with isEven on a list of numbers would result in a new list containing only the even elements, simplifying complex filtering logic. This makes predicate incredibly useful for operations like findAll or where on collections. Its Boolean return type is a natural fit for these methods. They leverage predicates to iterate through collections, applying a condition to each element and returning only those that satisfy the criteria, simplifying data querying. Now, let's connect these delegates to modern event systems using Event Handler and Event Handler T-Event args. These delegates form the backbone of how components communicate and react to occurrences within an application. This enables a highly responsive and modular design for your software. The standard event pattern in .NET relies on delegates to establish a publisher-subscriber model. Here, a publisher object raises an event when something noteworthy happens. Subscriber objects then register their interest and execute specific methods in response, without direct knowledge of the publisher. Event Handler is a basic delegate for events that don't carry specific data. Its signature is void event handler. Event args, empty, is typically passed as the second argument, signifying no custom event data. This is ideal for basic notifications, such as a simple button click. For events with custom data, we use Event Handler T-Event args, where T-Event args inherits from event args. This T-Event args is a custom class you define, containing relevant data fields or properties. Subscribers can then use this information to process the event effectively, providing rich context. Let's create a simple event publisher class, like a button with a clicked event. This button class will expose a clicked event that other parts of our application can subscribe to. The declaration public event Handler clicked notifies listeners when it's activated, adhering to the standard .NET event pattern. When the button is clicked, it invokes the clicked event, notifying all subscribers. This is typically done by calling onClicked, which broadcasts the event. All methods that have subscribed to the clicked event are then notified, allowing them to react synchronously to the button's activation. Now, let's create a subscriber that listens to this event. A subscriber is an object or code that expresses interest in the button's clicked event. Its role is to listen for the event and execute a specific method, an event handler, whenever the event is raised. We can assign an action or a lambda expression directly to the event handler using the += operator. For instance, my button, clicked +== console.writeLine, creates an anonymous method. This method will be executed every time the clicked event is raised. This simple += syntax concisely connects our event publisher to its listener. It abstracts away the complexities of traditional callback mechanisms. This allows developers to quickly and clearly define what should happen when an event occurs, fostering a highly readable and maintainable codebase. To pass custom event data, we define a class inheriting from event args. This custom class, like custom click event args, can include properties to hold relevant data, such as the time of the click. This enriches the context of the event for subscribers, providing more specific information. Our button class would then use Event Handler custom click event args for its event. When the onClicked method invokes the event, it instantiates and passes custom click event args, populated with data like datetime. Now, this ensures the event carries all necessary context for subscribers. Subscribers can then access this custom data through the e-parameter. In their event handler, the e-parameter will be of type custom click event args. Subscribers can then access its properties, such as e.clicktime, to retrieve and utilize the specific data passed along with the event. This allows for rich, context-specific information to be passed with each event. Instead of just a generic notification, subscribers receive detailed data relevant to the event's occurrence. This significantly enhances the flexibility and utility of your event system, enabling more intelligent and tailored responses. In summary, we've covered action, func, and predicate delegates. Each serves a distinct and crucial purpose in modern C# programming. They provide standardized ways to represent and pass around methods, which is key to writing efficient and expressive code, especially in event-driven architectures. Action is for methods returning void, func for methods returning a value, and predicate for methods returning a Boolean. Action performs operations without a return, func returns a specified type, and predicate always returns true or false for conditional checks. A helpful tip: always use these built-in action, func, and predicate delegates whenever possible. Prioritizing them over custom delegate types for common scenarios will significantly benefit your codebase. This practice is a cornerstone of writing modern, idiomatic C# code. They promote cleaner, more standardized, and easily maintainable code. Built-in delegates reduce boilerplate and make method signatures immediately recognizable. They enforce standardization across projects, leading to more easily maintainable code by simplifying future updates and debugging efforts. We encourage you to practice by building your own simple event-driven systems. Start with a basic publisher and subscriber, like a timer raising an event or a custom class notifying property changes. This hands-on application will reinforce your understanding and help you master these concepts. Experiment with different delegate types and custom event arguments to solidify your understanding. Try action for notifications, func for calculations, and predicate for filtering. Create custom event args to pass rich data. The more you experiment, the deeper your understanding will become, preparing you for real-world C# development. Thank you for watching this training video on C# built-in delegate types and modern event systems. We hope you found the content informative and empowering for your coding journey. Remember, practice is key to mastery. Keep exploring, keep building, and most importantly, happy coding.